Welcome everybody to this class about telecom demand. I am Teodosio Pérez Amaral, a professor from University Complutense of Madrid, and I would like to thank the Department of Chalmers University, and in particular Professor Eric Bolling, for his very kind invitation. I'm going to talk today about telecommunications demand, and let me give you the motivation first. I learned everything I know about telecommunications demand from Professor Lester Taylor, who is a colleague and dear friend from the University of Arizona at Tucson. I also learned from Robert Engel III, my professor and Nobel laureate, uh, whom I met in University of California, San Diego, and he told me interesting questions and interesting thoughts about how to do applied research, and in particular, one of his first ideas was if you want to do applied research, you have to think hard. Okay, so these are my two inspirations here in this for this particular session, and I would like to start telling you about what this is about. This is about finding out what are the effects of one variable or another, and in particular price on the quantity demanded of different telecommunication services. This is an important topic because the regulation is based upon this type of evidence. The discussions about universal service are also very important and based on these ideas. The decisions about investment and capacity are also based upon these facts and ideas, and they go through econometric models that work with the available data, and we are talking also a little bit, but not too much, about the competition and on different market services and data availability, and that is going to be also some side effect of the issues that I'm going to discuss today. Next, I would like to talk to you about some basic concepts that we are going to use in this area. And the first idea is that the consumption is not isolated. You have to do it through a network. There is interdependence of consumption, and that it gives rise to usage externalities. And those externalities are important for both the design and also the size of the network. The access, equipment, service provider, and usage are important components of the use of these services, and the network externalities again are important. Not only usage externalities, which I mentioned before, but also network externalities. Then you have the idea of option demand, and the idea of option demand means that you may want to demand a particular service just because you may use it and not necessarily because you want to use it. It is like for emergency, you may just want to have the option to use the network, but not necessarily to use it for sure. And then there are other dimensions of the different issues that I'm going to talk about today that I will mention later. The contributions to the theory of telecom demand that I would like to point out now are those of Artel and Averroes, von Ravenau and Stoll, Squire, Rolfs, and Littlechild, all of them in the Bell Journal of Economics and Management Science. They are devoted to mainly telephone, fixed telephone, but nowadays they can be applied to essentially any other of type of telecommunication services if they are extended as required. The idea is that I would like to tell you about is that there exists a demand model, and let us start with the demand model in which we have just one consumer and two goods, and then the consumer makes calls. You may think of this as enters the internet and lowers and downloads whatever he wants to download, and then he also uses a composite good. That means the rest of his uh, consumption is summarized using just a composite good, and then he does his consumption through a network that has capital N subscribers, and he has the choice of uh, using that dummy of delta, has a choice of either subscribing or not subscribing to that particular service, whatever it is that we are talking about. Maybe using cross-border e-commerce, or using e-health, or whatever we are talking about. Uh, if the consumer chooses to join the network, he will have a utility function in which he has a positive relationship with the number of calls he makes, with the quantity of composite good that he consumes, and then with the number of users of the network. Typically, you need some type of critical mass to be able to sustain a given network, and that is why the N appears there. And the idea is the more users that particular service has, whatever it is, the more utility the consumer derives from that particular network. And then you also have a budget constraint that tells you that you cannot spend more than you make. So that would mean the rental price plus the price of unit call price, which is pi, times q, which is the number of calls, and then that you add up everything you spend on the composite good, and that has to be equal to your income. So that is called a budget constraint in economics. It is very common. It is just telling you that you cannot spend more than you have, or than you make. Of course, if you want to you can um, modify this condition to allow for debt, but this is a simple way of thinking about this, and this is going to be useful for what we have. If we consider that a consumer is actually um, joining the network, what we have here is the consumer has to solve a problem that is maximizing his utility, maximizing his happiness, given that he is within his budget constraint. That is called a Lagrangian. You may know about this or not, depending on how much mathematics you have seen. But the idea is that in economics you use this to obtain demand functions. And those demand functions, in this particular case, are telling you how many calls or how many uses of the service you're doing, depending on the price of the service, the price of the rest of the goods, the composite good, P, then also the number of users of the particular um, service, and then the income minus r, the mu minus r, which is the part of the income that is left free after using a given amount of network that we are using and that we are deciding on using or not. So this is the basic framework. It is very useful. Then you also have the second decision, which is to subscribe or not to subscribe to the service. This is something that I'm not going to go in detail here. This is just to tell you that there are two decisions that are related. One is the use decision, the first one that we saw, and the second one is the decision of subscribing or buying access to the network. Of course, I'm thinking about general possibilities. I'm thinking about the access to different platforms that you may have in internet, talking about Netflix, talking about whatever other platforms you may be thinking of. You may be thinking of the decision of upgrading your router, um, whatever. So I want to be general in this. I'm not going to talk about any specific service, except as just an example. Now, uh, this is um, in transparency number 9. What I would like you to show you is what this arises to. So this arises or aggregate demands that depend on the price, the rental price, the number of individuals subscribing the service, and also income. This is important, this is useful, and this is general in the sense that this can be applied to many services. They're based on the previous type of questions and demands that we have seen. They can be upgraded or generalized to different types of calls, different moments of calls, different distance, different duration. So all those things have been studied carefully in the literature, and they have all been solved. That I just want to mention that those are possibilities that arise, and they are like an outgrowth of the specific developments that I'm talking. Here in section 5, what we have is something which is different from the previous one. And the idea is it is typically the case that when you have a new service, you have a service that it is not well studied yet, then um, you want to forecast the demand, because you need to forecast the demand to be able to adjust supply to the demand. And it is very important to see that the following approach that I'm going to talk about, which is the logistic approach, it works very well when you have very few observations, when you have data that are very scarce, and that is a situation that arises very commonly all the time, because every time a new service is out in the market, the first few um, years or months, you don't have much data to base your decisions on. So if this is the case, which is very common, then what you need to use is something that is called the logistic approximation. The logistic approximation is just using a, a little formula that you have here that it tells you that the rate of growth in the demand of a given service is proportional to the M, big M, which is the maximum, the saturation level, and the current value of the uh, subscriber base, which is Z of T. So on the left hand side you have the um, increase of Z over in at a given point in time over the number of installed bases of subscribers, which is C of T, and then this is a constant proportional to the difference between the saturation and the current level of development. So this is essentially calling you, let's go again over it. It is calling you that the velocity of increase is proportional to the size of the unsatisfied market. So this is something that makes sense, something that is typical of different markets, and it's typical also of different biological environments and different fields of knowledge. I'm just going to tell you that this is a common and useful equation, very small and very easy to understand, and it gives you to a formulation which is what you have here, a natural log of m, which is the maximum, minus ct, which is the m minus ct is the unserved portion of the market, divided by the served portion of the market, and that is equal to alpha plus beta t plus ut, and that is telling you that this particular log of the part of the market which is not served yet is related to time, with parameters alpha and beta that need to be estimated. So this is the idea. This is a very simple idea but very useful. It has been used in many markets around the world, and it is something that a lot of the consultants know, and they sell this type of device very well. What is this useful for? This is useful for doing out of sample forecasting, and it is useful for doing some time series out of sample forecasting. It has a very big advantage over other different frameworks, and it is that it has minimum requirements of information. This is very useful because it is very common to have minimum information in new services, essentially. These are the advantages of the logistic approach, but there are other disadvantages. One of them is that the elasticities are not estimated. We don't know about elasticity. We don't know about the effect of explanatory variables on the dependent variable. We don't know anything about that. We can think of this as one way of doing a forecast. Another possibility would be to use ARIMA models if that's okay with you and it have enough data. And another problem is that treating the maximum as a constant is useful for short periods of time, but it may be not useful in the cases of longer periods of time. In general, you see that Chada and Chitgopegar propose treating m, the maximum, as a variable which depends upon time and population and prices and all those situations give rise to cases in which the maximum or the saturation point is increasing with time. That is very common, very useful, and it has been done in many cases. Another area that I would like you to bring your attention to is the telecom demand by firms. It is a difficult area. It has a lot of heterogeneity in firms, and therefore the standard framework that is used, that is writing a production function and obtaining demands for inputs using the economics and basic economics, is problematic because um, of heterogeneity, basically. In these cases, the telecom input may be a vector of inputs rather than just one input. So if you think of a firm, a large firm, in that large firm you may have uh, different packages attending to different characteristics. You may have single lines, fixed lines. You may have packages of other types of lines, maybe also access to the internet, access to different type of services, and that would be um, a possibility that may be very heterogeneous between firms that have, for instance, just one person working on the firm, than in other cases in which you may have thousands of people working in the firm. So the needs, communications need, may be very different. In this particular framework, the demand functions of inputs, and in particular telecom inputs, are derived as a function of the prices of the different telecommunication services, the technology that's being used in the firm, the prices of other factors, and also the levels of production of a given firm. It is important to notice that in the analysis of telecommunication demand by firms, we have to use the data that are as disaggregated as possible and use models that are specific for that particular maybe branch of the industry. And that is important because if you have specific ways of dealing with different branches, that is going to be much more easier to customize the models to the particular needs of the particular sector. And then you have to see, like here in transparency number 18, that you have this match. The idea is you have to use in particular the logarithm of lines over the volume of production, and that is a function of a constant alpha 0, alpha 1, which is another constant parameter that affects the type of services that we call E1, and then the type of services that we call E2, and then the prices of the different lines or services, which are PL, PT, and PS. U is an error term, but this is just a regular regression framework equation, except that now we know a little bit more about the functional form. We are using logarithms, and we are using also the ratios of these particular prices that we know that are better than just using them in an isolated way. So telecom demand by firm is more difficult, but it can be treated. It has been treated in many papers. As a conclusion, let me tell you that we have seen that are solid theoretical literature on individual demands by firms or by uh, private individuals, that external effects are very important in the sense that if you are using a service that is being provided through a network, the network is going to mean that the bigger the network is, the more valuable the service is for you. And again, the usage effects are also important in the sense that um, if you're using a given service, then it is very common that your use affects the utility of other people. And that means that your use either is positively affecting the utility of other people or negatively. So you think of a person that is being annoying uh, through the nets, through the networks, or through social networks, then that person is going to have a negative effect. And if you're someone who is nice and an influencer, then your effect is going to be positive, and a lot of people are going to benefit of using uh, whatever, Instagram or whatever, because your use makes them happier, and you increase the utility of other users. And here it says that the network effects and usage effects mm, are more important at the beginning of the service because that is critical for the service, but less so for mature services. Also, the models that we have seen in the section 3 here, the models that can be adapted to specific situations, and that is important because that helps you uh, be able to answer specific questions that the industry may have. A general idea in all this literature is that disaggregation is very important. It is the best way to do things is always disaggregate to the individual consumer level or the individual firm. And on top of that, it is always advisable to look at not only composites of services, but also specific services, and that is usually much more useful than just uh, talking about general uh, packages. Talking about now the logistic model, it is an alternative strategy. It can be very useful for short-term forecasting, and it is important that only limited information is available. Heterogeneity is an additional difficulty for modeling telecom demands, but disaggregation can be useful to deal with heterogeneity. And last but not least, you see that first principles are still useful for analyzing new services. So I'm not going, I haven't been very specific in talking about new services, but you can think of things like cloud computing and all kind of different services that are consumed over the net and that are very useful to be analyzed with this kind of framework. Okay, thank you very much.